Hi, I'm Holly Yanco. I'm currently at the University of Massachusetts Lowell, and as of September, I will be at the University of Massachusetts Amherst, moving down the state, across the state. When you do a Google search for human-robot interaction, you get this. Robot and Frank has made it into 2 of the 4 talks in this session. So you get a lot of the birth of robots, the birth of man, whichever way you want to look at it. I think about human-robot interaction incredibly differently. I call these my family photos. So this is what it looks like in my lab, a lot of the robots that we have. So robots that people can wear, exoskeletons, assistive robots like scooters and wheelchairs. We have a fetch robot, Mars rovers, some humanoids, quadrupeds. So a wide variety of robots. But all of them, in some sense, need to have HRI. It's all different HRI. And I would like to lay out here in front of you my bold claim that HRI is robotics. All of robotics. I claim it all. It's all mine. You can have it too. But there's always that person. So I'll give you epsilon. That is not HRI. But for the most part, when we think about doing robot systems, if you have a better path planner, it improves human-robot interaction. If you design a better robot system, it improves HRI. And if you are designing a robot, you should be thinking about HRI from the outset. Don't think about it after you have the robot. Think about how you're designing for that. So the elements of HRI that I think about a lot are capability, and I use this word intentionally. I think we use the word autonomy a lot in robotics. I'm not sure we really want fully autonomous robots. We want fully capable robots. So you want the ability for our robots to do great things, but maybe not doing everything completely on its own without any input from us. And then, of course, usability, understandability, trust and safety are other components. So I'll talk about some of those in this talk today. So the first thing I want to talk about is how do we give feedback to robot users? So how do people know what the robots are doing? So in one case, this is a project that's collaborated with Rob Platt at Northeastern University, so working on having assisted grasping of unmodeled objects and cluttered. So in the United States, when you go to grocery stores at the front door, there are these scooters that you can use if you have trouble walking around. But what they don't come with is a robot arm. So we're imagining, what if you could put a robot arm on these scooters so when somebody goes around the grocery store, if they can't walk well, they may not be able to reach high or low either. But when you look at a grocery store, you have all of these products of very many different types. The packaging changes constantly. Right now, we're seeing packages getting smaller. Oftentimes, there'll be advertisements on them, so they'll change what they look like. And all of those products are very conveniently brought out to the front and all. Nice wall. So how do you do that manipulation? So Rob focused a lot on the manipulation in this project, and we focused a lot on the interface. So we were thinking about how can we have people select objects with the scooter? So we're trying to think about if you pick this up at a grocery store, you need to be able to use it easily without a lot of training. But we don't want people to be spending their time looking a lot at a screen. So we started thinking about, could we turn the world into its interface? So we mounted a projector on top of the scooter, and then we can highlight objects in the world. So we created effectively a fake laser pointer through the projector, and then we have the ability for people to select objects. So a study on this project is going to be presented on Thursday in the 9:55 to 10:30 track. Please come see the talk and see the poster afterwards. Another thing that we think about is if you're wearing a robot device that's adapting with you. So if the algorithm is changing as you're wearing an exoskeleton, and you're the person wearing the exoskeleton, do you think it's changing, or do you think it's not doing the right thing? So adaptive exoskeletons, you may use these over the course of a day because people get more tired over the course of the day. So they've had a stroke over the course of the day, they need more assistance. So we want to provide that assistance, but if we're changing the algorithms constantly, how do people know what's happening? And do we give them a chance to reject that change? If people don't understand what's happening with their robot system or any assistive device, there's a lot of abandonment with assistive devices. So we need to think about how are we providing this feedback to people as they're using this. If we have feedback, how does this influence people's trust of a robot system? Is feedback always good? So with Aaron Steinfeld at Carnegie Mellon, we did a series of studies looking at trust in human-robot interaction, where we had an old ATRV junior robot, in which we were using to go and do a slalom course. With different reliabilities, we basically forced errors, because if you don't have errors, then there's nothing to figure out if you're trusting or not. Developed a method for measuring the area under the trust curve for real-time trust. And for feedback, we looked at these different types of providing feedbacks, whether it's a plus, a 0, to minus, which we call non-semantic, and I hate that we did that now, or semantic with the smiley faces. But the feedbacks are presented in that gray box there to the right of the image of the robot. And so what we wanted to see is if the robot told you before it was going to fail, would you trust it more? Kind of like if you think about when you were taking classes in your group project and you're working with somebody and you don't know them, but they say to you, I'm not going to get this done in the next 2 days because I have to go to a funeral, I'm sick, whatever, as opposed to just ghosting you. If they tell you they're going to fail, is that better? Will you trust them more in the future than if they don't tell you anything at all? So we ran experiments where we had 12 participants experiencing just the failure cases, what we call the dynamic reliability. And then we had 16 participants experiencing the dynamic reliability with feedback. When we split that into basically the 2 different conditions there, whether it was semantic or non-semantic. And what we found here is that the feedback didn't produce any difference in the trust of the robot system at all. They did have a better control allocation strategy in the tasks that we were running, which I didn't tell you a lot about. But the control allocation, they decide whether they would let the robot run or whether they were going to take control. But it did increase their workload and increase their mode switching. And I think part of the reason for this is we had those 3 conditions that you saw here. We had, my confidence is high, everything's good. My confidence is neutral, everything's okay. And my confidence is low, now I'm having problems. So if you think about the workload there, if you have something that you have to monitor and it's like, I'm good, I'm good, I'm good, that's a lot of workload right there. So what we really found is that you need to provide feedback only when the robot is failing or about to fail, not when it's working properly, which makes a lot of sense. So given that, how do we determine when robots are going to fail? And once we do that, how do we think about conveying that information? So we've been working on explainable systems, both reactive and proactive. So reactive is when after you fail, you say, I failed, and you give an example as to why, a reason as to why you did that. Proactive, trying to figure out that you might fail. So we've been using behavior trees, and Xiao Han, my graduate student who's now an assistant professor at University of South Florida, had started this work. And we have this whole architecture for reactive explanations. And then we added onto those the ability to use assumption checkers, which came out of Brigham Young University, to look at having a proactive explanation architecture. So with the behavior tree, we know what node we're at. We can use an assumption checker to make sure that we have the conditions to go forward with what we need to do. And if we don't, then we can proactively say, we're about to fail this task because of this. So when we're thinking about these explainable systems, we found that in our experiments, they're rated as more intelligent, trustworthy, understandable, timely, and preferred. But one thing that we also tried is we tried using LLMs, because of course everybody's using LLMs now. We were using templated explanations to start off with, but then we thought, well, templated explanations could have problems. And what we found in our studies is that people said, the language is not good, right? It's not good English. So we don't think the robot is very smart. So we thought, oh, if we move over to LLMs, then the language will have better grammar, and people will perceive it as being smarter. And what we actually found in our initial work here is that they actually weren't better. People actually preferred the templated language to the LLMs. And we think that that's partly because we were not providing enough context. So there's been further work on this I don't have a slide for, in which we're looking at providing images of the situation the robot is seeing, like images from its camera, for the prompt, so that it can actually give very specific reasons as to why it's failing. And in that case, we're finding that there really aren't any differences between the templated language and the LLMs, which is a little bit more what we would have expected. So I wanted to end with some open questions that I think about in HRI, kind of going similar to what Harold did. Is HRI going to change as systems become more capable of autonomous? I hope so. I mean, certainly I hope we're not joysticking robots 15, 20, 50 years from now. Right now, downstairs, a lot of those robots are being controlled by joysticks, right? So it'd be really nice to not have to do that. It'd be nice to have them figure out what the intent of the person is, to do things to help us in a very capable, not autonomous way. So given that, how are HRI designs need to, do they always need to adapt? Can we find some steady state? I feel like, just like we're in the Wild West of robotics right now with all the different robot systems that we have downstairs in the exhibit hall and beyond, we sort of are in the same place with HRI. So we design lots of systems, we conduct lots of studies, but What do we take from that, and how do we come to something that's a bit more generalized? How do we think about accounting for people's experience or lack thereof with other robots and technology? How do you get that common mental model? Can somebody walk up to your robot and say, oh, well, I have seen Spot, and I have seen this robot and that robot, and you go, okay, I know how you're going to expect things to do. Or can they walk up to your robot and you play them a 10-second video or 10-second example of what you can do? That's kind of the same thing that we heard with the robot explanations that Sonia was talking about. So how do we design based on what people have seen and what we want them to know about our robot systems moving forward? How fast can we get people to understand what we can do? And this one, I think, is a really hard problem. How do we create a model of HRI? So we've done tons of human subject studies. In the old days, we used to run studies on 5 or 10 people. Now we're running studies on hundreds of people or thousands of people if it's online. So we're getting all these results, but how do we pull them together? How do we get a computational model of human-robot interaction? And if we can get that model, what parts of it are static? What parts of it change over time? When I first started doing robotics, because I'm old, we had to build our own frame grabbers. Everybody who built a frame grabber? I can't be the only one in this audience who built their own frame grabber. Now we all have these, right? This totally changes how we interact with robot systems. So as people get new tech, it changes their expectations. As we have new robots that are in the homes, that are in the world, it changes expectations. What part of a computational model could be static? What part changes? And how do we create that model? And that's what I'm going to be thinking about for the next couple of decades. Thank you.
Thank you. Any questions from the audience?
You're just going to be the HRI as robotics? This is awesome.
Hi, question here. Great talk. My name is Maria. I'm a postdoc at MIT working on HRI. And I really liked your example of the arm in the grocery store, something that I wish I had sometimes. How do you also include what a person's reasoning might be to choose a specific grocery item? For example, if I want a mustard, I'll probably dig to the back to find the one that expires at a later date. Are you also thinking of how to integrate not just how to pick up an object, but how to pick up the best object?
I gotta say, we did not think of that. That would be one heck of a dairy pull for us. So we didn't think about pulling the back objects just because the grocery stores we were working with would probably not be happy with us dropping more stuff on the ground. But it's a really interesting thought to think about how could you try to have priorities like that built in.
I have another question. Also great talk. To what extent do you think people care about whether explanations are approximate versus like provably correct? Because LLMs presumably generate approximate explanations of robot behavior and are not necessarily tied directly to the robot control.
So the LLMs, we are prompting them with the controller and the context that the robot's seeing. So it's certainly not going to be provably correct, but it's not operating in a vacuum. We are prompting it with the information that we have from the system. So it is prompted with the behavior trees, it is prompted with, and actually some of the prompts we've been changing is trying to get the system to prompt to, because we're prompting with the behavior trees, then say, back off and pretend you're a novice user, right? That has to be part of the prompting too, because otherwise the explanations are too complicated. I think in general, if you're talking to the general public, they don't care about provably correct. I don't think they'd understand it. I think what we're trying to do is give people an idea what the robot's doing, and I think that we as people fail to communicate as well. So I'm not sure that that's going to be something that's going to be necessarily required, but I do think it is application dependent, right? If I am in a situation where there's safety critical, and I'm going to go into a building that's collapsed and do something, I need to explain why I can't do something, I really don't want to give the wrong answer and cause a building collapse if somebody goes and tries to push the robot forward. So I think that it will depend on the situation. If I have a robot that's picking something off a table, less important.
All right, thank you.
All right, thank you so much, and thank you for attending.